Thank you very much, everyone, for coming. Thank you very much for all the speakers. I'm pretty excited that we have this first version of the Spatial App Development Summit. Also because I think that has been an amazing ride for CARTO that we released 3 years ago the first version of the CARTO module for DeckGLs, and it has been a very healthy collaboration for the DeckGL community, and we have been able to align very well the open source strategy for the company and also for the DeckGL community. And yeah, super happy to be here talking about creating different geospatial applications. And today I'm going to try to explain how I think that we should try to modernize app development when it comes to develop today a new geospatial app for a mapping application. We have seen that the evolution of DeckGL during the last few years has been super great. Is that represent this chart the number of downloads that we have per month, and we can see how we have increased a lot from that time that we started with 250 and now we have more than 750 downloads per month. Also with the CARTO module that is started and it's around 300,000 downloads per week, and that is looking pretty nice. And that is how I define what is the journey to develop a spatial app. That if I need to define this, that I think that we have mostly like 5 blocks that we need to develop. Some days you need to invest more time in one, in other, but it's like you need to work on base maps, you need to do some kind of data engineering work, some kind of spatial analytics, and some kind of backend services, and finally, visualize your data. And I'm going to try to explain how I think that CARTO can help and how we are trying to reduce and to make easier this journey. For the base map, I think that CARTO have nothing to do. That is like the strategy of DeckGL is just to be agnostic, because there is already technology up there that you can just pick up to visualize and to create your spatial solution that depend on what you want to use, that you can use Google Maps, you can use MapLibre, you can use Every, Mapbox, Azure Maps, Amazon Locations, but it's nothing that CARTO needs to add there. But here, where it comes to data engineering, I think that's one of the strategies of CARTO that is cloud native and is based on SQL, reduce a lot of the work that you need to do when creating a spatial app, because you don't need to move your data to an external geospatial tool to be able to work with your data spatially. Also with the data observatory, that you need to license in your data and all the stuff that is not trivial. Also that as we are based on the cloud native things and SQL, is you get something that is coming for free, that is using the warehouse tooling, that imagine that you are in Snowflake, you can use the SDK from Snowflake, or from BigQuery, that you can use the SDK from BigQuery, from Python, and all the things that come directly out of the box, or the data product that they have for data engineering. For spatial analytics, we launched a product last year in the Spatial Data Science Conference. The adoption is looking pretty well. And we will talk today about how we are integrating that piece of software that is called CARTO Workflows to do this very basic spatial analytics from our application, how to integrate with an API and so on. Because at the end of the day, if you are building a geospatial app, it's because you want to share some kind of insight. It's not just pure visualization in general. So this kind of very basic analysis are pretty easy to do with Workflow, so we can reduce time there too. But the biggest part, I think, that comes here. I think that the biggest part comes when you need to develop some backend services, and that you need to develop APIs to bring the data from your data warehouse, from your data structure, finally to your customers, that you need to implement authentication layers, authorizations, get some APIs to control the access to the data. That is not trivial. And that is not trivial not only because of the software that you need to develop, also because of the infrastructure that you need to keep up and running, setting CDNs and things like that. We started with this project back in CARTO, like in 2 years ago, with the goal to reduce to zero the professional services involved in for the professional services that we need to do for our customers. and we have reduced almost to zero today. And as we are not creating backend services, we don't need to deploy that. So we have also reduced the infrastructure part. And I think that is pretty straightforward, that you don't need to create APIs and so on. And the rest is for visualization capabilities. I think that DeckGL cover this very, very well, because if you want to create an advanced visualization, like visualizing an S3 layer, how to visualize your 2D data on top of a 3D tile layer, and things like that, I think that DeckGL covered that very well. And the glue with CARTO and the data warehouse allows you to connect to a scale up on the volume of data that you want to visualize. DeckGL works on the client side, but connecting a backend like CARTO, you can grow to visualize large and very large data sets. As we can see, we have a lot. I think that is, for me, that's great value of DeckGL, that you arrive to this page and you see how many kind of visualization that you can create, if you need to go beyond of the capabilities of the base map library. Companies like this one, like the Streetscape, use already DeckGL to visualize the data from cars for the self-driving cars and so on. This project is looking really, really nice. One of the very important things is that be strategic by choosing the technology. The first one for me is be super lazy. I love these guys that you have on your team and are developers that I define like they are super lazy, because they don't want to do more things than the things that are required. And that is very good, because the fewer code that we have, the simpler code that we have is the better. And those kind of things is super interesting. The next step is just to find areas of acceleration. If you need to create an authentication layer, don't develop that on your own. There is something out there. If you want to use a base map, don't develop that on your own. Just use Google Maps or use MapLibre or whatever other option. And the other is also very important, is free benefits in the long term. That is something that you need to think about. That is like, this solution that I am using is going to give me benefits for free in the future? If the answer is yes, it's probably the right solution. That is happening with a few examples. For example, right now with DeckGL. DeckGL is working a lot right now to bring support to WebGPU. That is the new standard, the evolution of WebGL. And you don't need to worry about that, because DeckGL is going to work on that transition, and that is going to take care of that. Same things with that data warehouse. That is like, you don't need, if you are using SQL and you are using the standard, you don't need to worry that if they are going to scale up, if they are going to provide some third-party libraries like Python notebooks, like data frames and so on, that is going to come to your product for free. And that is what is very important when you need to decide the technology that you're going to use when building a geospatial application. In the past, it was a little bit different. In the past, it was like we were trying to develop almost everything or use some piece of open source and so on, but this has changed. So we have worked a lot about, I have talked a lot about the theory, but let's try to see that in action on a real use case. Imagine that you are trying to build an application in CARTO, and one of the things that you have is a table that you have your stores, and the other is a table that you have the revenue per day of each store. And the first step that you want to do, for example, is to just visualize. You can do that directly, just put the name of your table, and you get your stores available. That is not rocket science, but that is the first step. But what about the next one? What about if you want to say, I want to know what is the revenue of my store per zip code, per state, and things like that. If you need to develop that application, that could be a little bit tricky, because the first thing is that, hey, where I can get those boundaries into my data warehouse or into my any other data store, and how to calculate the intersection between the data and the boundaries. So I need to create different endpoints for doing that. So how we are going to get the data? So for CARTO, the first thing is that we have the data observatory, that is a catalog of 2,000 data sets that you can directly subscribe. Many of them are free use, and in this case, we are just subscribing to a zip code data set. And once you have subscribed, you have that table already available. The next thing is that probably you have a layer of the boundaries of the states, and you can do the join. The join is not complicated. It's just an intersect, calculate a point in Polygon between the state and the stores that are inside, and then group by the state, and then just calculate that sum. It's quite direct using SQL. But that is the powerful of using SQL at CARTO, and you can use that securely even if that is a public application, because our APIs take care of protecting you from SQL injection and all of those kind of things. But you can say here, well, that's good, but I can do that easily on JavaScript. That is like the number of states is not quite big, so I can do that. But what happens if you have a layer of zip codes? There, the things are far more complicated, because you cannot have all the data on the client side, that you need to do those kind of things. And what happens if you want to apply some kind of filtering for the data and create a component that allows you to filter the data between 2 days, for instance? In this case, it's the same. It's probably the same query, but we have had something that CARTO incorporate that is query parameters that can be used also in public applications, and they are protected from bad usage in public application, because you can have these query parameters are protecting you of using that token on a public application where someone can do a lot of different queries. At the end of the day, you don't want to put a token in your public application where the people can do any kind of query to your data warehouse, because you will need to pay for the bill, and probably you won't do that. Other things that is like with CARTO, you have also the CARTO Analytic Toolbox, and you can aggregate data in H3 indices. So with this very simple query that you just calculate for every single point, you calculate what is the H3 indices, and then you just group by the indices and you sum by revenue. That is quite direct, and you have a map with an H3 layer. But that's good, but they are not really big data sets. What happens if we have a really big data set like this one? Imagine that you have a table that it has all the buildings of the world. That is like more than 400 million polygons, and is more than 100 gigabytes of data, 119 gigabytes of data. What CARTO provides here is that you have functions inside of your data warehouse that you can use, and you can create directly tile sets. You don't need any kind of backend, you just use your data warehouse that scale up very well, and it creates directly the tile set for you. And then, probably in this case, BigQuery will, or Snowflake or Redshift will launch different machines for that calculation, and then you can visualize a data set like this with this performance. In this case, the cache is not enabled, and you can visualize and you can get the speed of visualizing this data set with so many polygons all over the world. So I think that is when CARTO starts bringing a lot of value. Imagine doing this without this, it could be a real challenge, using TypeCanor or using other open source things that is not so direct. Other thing is that you can say, hey, okay, but how much is going to cost me? How much the tiles are going to cost to me? The good thing is that we estimated that the data is already clusterized by the tile itself. So when you are asking for a tile, you are only assessing that region of the data. So that is very good, because the byte that you need to process, that is usually the metric of churn that the warehouse does, is very, very low. It's 0.00021 per one tile request. What means is like 21 cents for 1,000 requests. That is if you don't have any kind of cache and any kind of BA engine. So that is faster, and that is also cost effective. But then CARTO also plays this kind of thing that we forget about that when we are creating a public application, and probably is the responsibility and the cause of most of the crashes on those kind of applications. That imagine that you develop that one mapping application, you put in a web server, and suddenly you receive a lot of requests. What you want to avoid is that your application is down, right? So what CARTO does here is that we put a CDN in place, and we have an advanced cache system that if you receive 100 million of requests to a single child, only one request will arrive to our Maps API, and only one request will arrive to the data warehouse. And it will stay there for 1 year if the data have not changed. If the data have changed, it will be refreshed automatically. You will have also the flexibility to control the cache using standard cache control from CARTO, but that is another piece that I think that is very important when you are developing a mapping application. And that is something that develop on your own could be hard. And this other, I think that is one of my favorite. That is one of the cool things of CARTO that we have seen before is that CARTO can understand not only geographies or geometries, it can understand also spatial indices. And those databases that the different data warehouses like Snowflake, Redshift, or BigQuery, they are extremely fast when they need to work with numbers. So in this case, I'm going to show you these examples where we are going to visualize in real time a table that have 600 million rows. And I'm going to apply a filter here dynamically that I'm going to use wherever 3.0. And let's see how fast it is to get the data from a table of this amount of data. These calculations are running on real time against the data warehouse, and you can move around the things. And that is pretty straightforward. You just put the H3 indices, and then you have an aggregation expression, and you specify the column that you want to use for the H3, and you will get your map. And how is that possible? How is that possible is because at the implementation, as I said before, these databases are extremely fast when they need to operate with integer numbers. And what we take advantage is of the encoding of the H3 index itself, and we clusterize the table by that index. So that means that all the data is put together in the same place. And we use the H3 tile system to visualize the data, so we are not using sets SY. So in this case, we are using an H3 indices. So what that means is that we can calculate and apply this kind of range queries to get only the data that is required for your child. And that is super cheap for visual. For a table that have like 30 gigabytes of data, we are only scanning this amount of data. That is like less than 100 megabytes to get the data of a child. That is one child that is bigger, I have to say, but the other will be even smaller. And what happens if I want to go even further? Hundreds of billions of rows, that would be possible also using a spatial index tile set. In the same way that you create tile sets for geometries, you can do the same, but for spatial indices. Good. That is everything related with visualization large data sets. I'm going to show a little bit right now about this demo that we built with Google. It was developed also, 1 second, let me try to open. Because there is a lot of technology that we developed for this demo. And I would like to explain a little bit. What we try to do here is to visualize the GL data on top of Google 3D tiles. So for creating this demo that will try to represent why it's important the vegetation for cities and to control the temperature, the first thing that we did is say, hey, okay, we are going to try, let me go back, to visualize a satellite image of the temperature in Prague. We use Prague because Felix is from there, mostly, and we built that solution. And the temperature raster we get this raster from Google Earth Engine, and we will import that into BigQuery. So that is a solution that CARTO offers that you can take your GeoTIFF and visualize directly using DeckGL. And you can apply different filters and so on. And this is what is available here in the team. The next things that we develop is this feature that comes with the terrain extension. That is like, we are going to visualize 3D tiles, but then we are going to allow the people to use to the data to visualize and to adapt this data to the third range surface. That was a pretty challenge, but we worked together with DeckGL to be able to implement this. And in theory, any kind of ledger in DeckGL can be visualized inside of a 3D tile. In this case, I think, if I remember properly, we are representing here the distance from each building, and it's a tile set, right, Felix? It's a tile set of a table, and yeah. So another thing that is like, we talk about a raster, so you can figure out hey, how we can visualize a raster and how that is connected to BigQuery, that is a standard database that doesn't understand about raster. So basically what we do is to encode a raster in an special index compact format that we have developed to be able to have the raster inside of the BigQuery database. And the process is, at the very beginning, you just use GDAL to convert your raster to a cloud optimized GeoTIFF raster. And then we have a command line tool that you take your raster and you can upload that into BigQuery. And when we upload those data sets, we convert to that specific format that we can use later for faster visualizations. And for faster visualization, basically what we develop here is a format where the data is sent directly to the GPU, and the GPU is able to visualize very fastly. Yeah, that's all regarding visualization. Another feature that is available is that you can also get the value of a specific point of your rasters. That is very useful also for telco companies that they want to have a raster to analyze, for example, the coverage of the network, and then they have a public application that they click on a specific point and they get the value from that, and using a cost-effective way. In this case, we are including a point, but you can also have a full table, or you can have a bigger area of interest with a polygon or a multi-polygon or any other. At the end of the day, it's just get the value of an area of interest. That is everything regarding raster and the feature, but I would like to talk right now about what is coming next. What are the main features that we expect to release during this year and in the next one. First one, I mentioned before, that is workflow. That one of the ideas is to extend the parameterization and app integration capabilities, because what we want at the end of the day is to use that from our applications. So one of the things is that now it's possible to create a workflow and create different parameters that you will use at the time that you execute that workflow. And the other step is that you can also enable an API endpoint for that workflow. So you go to the workflow, you click on Enable API Access, and you will get an endpoint that you can use to call the workflow programmatically. Next thing about DeckGL version 9. That is almost there. We are working on trying to fix other things. That is going to be a new major version of DeckGL. And we hope to release that in November, early November. And one of the things that that are super important is web GPU support. That we have adapted the API layer that we use to use web GPU or DeckGLs, and the idea is that the project is going to work during the next few years with both. And we are going, if web GPU is available, we are going to be to use that, but if not, we will use the WebGL, and that will help us in the transition during the next few years.
Slightly to frame your brain, it's not going to be quite in 9.0 for hardware GPUs, probably 9.1, but a huge amount of work has been put into providing the groundwork for that. So we've kind of done the work to make the switch easy in the future,
Yeah.
But it's probably going to be a few more months before we actually show that.
Yeah, it's more on the having like the API bridge that will be used, and then we will be incorporating more and more layers for that. But the idea is that it will be transparent for the users. What we have been changing is that the rendering engine of DeckGL is LumaGL, and we have created like an abstraction layer for that. Thank you, Felix. The next thing is that widgets, that we are going to have a new module in DexGL to allow support for widgets that will allow you to put your map on full screen, to have a legends, and the idea is to incorporate more and more of that. The idea is that it's a module that has been asked a lot by the community, also for our user of CARTO, and we are going from CARTO, we are going to invest in that too. There is a working group in the DexGL project that we are going to start working in that part. The other thing is that TypeScript, the types will be exposed directly at the root packages. We have been working in TypeScript a long time during the last couple of years, and that will be finally available in the root package. I think that almost everybody that is developing today is using TypeScript. For the CARTO module, we will have a new version of and a new API for that. That basically what we feel is the CARTO layer needs to evolve. At the very beginning, the CARTO layers basically represent only vector data, but we have added a spatial index, S3, and quad beans, and also we have added raster support. So I think that's for making it more clear for the users, making it more explicit, we are proposing a new API where the user needs to provide a table source, a source object that will be used then in the final layer. Because right now there is a little bit of magic that says if you are using this prop, you will get an S3 layer. If you are using these other props, you are getting a raster layer or a vector type layers, and it's a little bit not very intuitive for that. That is the sample for an S3 layer, that you will use an S3 query source in this case, that you will use the SQL query, the aggregation expression, and then you will use an S3 type layer. That will be the layer that you will use for rendering. The other things, that is probably something that the user at CARTO have asked about a lot, and that is part of the work that we want to do with widgets. We call it that data widgets, that right now, if you want to use widgets in your application, you need to use a library that is provided by CARTO that is called CARTO for React. The problem with CARTO for React is two things. That is, one is that you need to be a React user, and the other problem is that you don't have enough flexibility. So we started in CARTO for React with 3 widgets, and we have right now 8. And I think that if we continue like that, another option could be that, hey, let's create a multi-framework widget feature, but I think that you will be in less than more asking for more and more widgets, because it's the normal thing that we are developers, we want to extend capabilities, we want to modify things. So one of the things that how we are going to address this project is that we want to have something that is available in any framework, that could be like a DexGL module that you can use, and then we want to use an open source library that will give us more flexibility, not like giving you the final widgets that you want to use. No, we want to use an open source project that is in charge, that have a lot of different widgets, and like in this example, there is a cow that is like, we want to create a widget. If we provide the data and you want to use this way of visualization, that's fine. If you want to extend, that's fine. Even if you want to use another library for rendering the widgets, it's also fine. What we need to build is kind of the bridge between DexGL and the data of your widgets, and then you will have the flexibility to go further with those widgets. Apart from that, we will include a set of widgets that are like the standard widgets of CARTO in the future, but the idea is first focus on giving that flexibility for everybody. The last thing, I think that is a feature that we have been working during the past, and we expect to have in private beta during the next month, and in public beta during this year. That is the new API that we call is boundaries. In this case, as you have seen, that either Mapbox or Google Maps has the flexibility that if you want to visualize a table of zip codes, you don't even need to create a subscription, you don't need to import in your data warehouse. So it's like, hey, I want to have a layer index.jl that I will give the boundary ID, and I will be able to visualize that boundary. That would be possible with this API, and you will be able to visualize a boundary. But that is not the good thing, because the good thing is that we want also to provide visualization for data when you have a table that you, like this one, that you don't have a geometry column, you have only a zip code and the population and revenue. We want to provide you the capabilities to be able to visualize that table, even if you don't have a geometry column. And why is that? Because that is going to allow us to grow a lot, also not only giving the user the flexibility of visualizing a table even if you don't have a geometry column. That is not only that, it's also because we think that we can also increase the performance. In this case, the layer will be that the API will be like this, that you will have a boundary ID, and then you will have a properties query source that you can apply to your layer. And here, you will define where is the other table that you want to use. So in this case, what will happen is that this layer will join both datasets, the zip codes and the attributes for this other endpoint. And the good thing of that is that it's a great performance boost for dynamic tiling, because it doesn't make any sense when, in the previous example that I shared, we were doing the things with zip codes and applying different things in SQL. But the problem with that is that we are applying all the geometry computation and all the geometry calculation for the tiles again and again. And what are those operations? Those operations are simplification of the features, transformations, calculation of the area to apply that dropping, because if you are a Asuero, you need to remove the features that are less prominent. All the things that are not required in this case. If you have a data set that is dynamic and you have the strip column there, what we can do is that CARTO will pre-generate a set of geometries, and the client side will go directly for the geometries at one point, and the geometries are ready, and we don't need to do any kind of extra operation, and then go to another endpoint to get the properties. And then the layer will put together to bring that to your visualization. So for the client side, it will be like having all the things together in the same place. We hope that we are working right now in that, and we hope that in just a couple of weeks we can have a preview of these things. And that's all. So thank you very much.